All right, welcome back, guys. I'm so sorry I forgot about the CER that we are adding to this lesson as part of our practice in proving things. So the question that I have given you already, it's already posted there, is are the lines in the graph parallel, perpendicular, or neither? The claim that we are given is actually pre-listed for us. So I'm just going to point that out for us. The claim is pre-listed right here at the top. The lines in the graph are parallel. So that is what we are trying to support the statement, prove or disprove that. And so here we want to look at focusing in on parallel lines, since that's our main focus going forward. So I'm going to switch colors here real quick. And in order to figure out if the lines are parallel, I need to know something about parallel lines. So I'm going to go to my evidence for a minute and just jot down something I know about parallel lines. So parallel lines, I know for parallel lines, the slopes must be, you could say must be equal or the same. So I'm going to say must be equal, but I'm going to make sure we know that means the same. Okay, so that's some information that we know that's really important. That's how we're going to prove this. So I'm going to go back to my picture and see what else I can do with that. So I know the slopes are supposed to be the same. So I'm going to see if I can figure out if they are in fact the same. I'm going to start with my purple line, the one on top. And I'm going to look for a place where the line perfectly crosses a corner. Like right here, there's a corner right there. Well, my purple line doesn't cross there, but that is a point. That is a perfect corner. I see one right here. And you could pick any one on the line. I'm just going to pick this one. And I'm going to count the slope. I'm going to do a quick reminder that slope is the same as slope we represent with the letter M. And it's the same as rise over run, or the rate of change, how something is changing, but we call it slope, rise over run. All right, so on my purple line, I'm going to count till I get to the next place where my line crosses a perfect corner like that. So typically I go left to right. So going from the point I'm at, I'm going to move to the right side. So to do that, I have to go up one, and then I have to go over two. Now, you could have also done over two and up one. It doesn't matter which direction you go first, whether you go up or down, or left or right. It is up to you. So this represents my rise. I rose one, and then I ran, or my run was two. Okay, so then the slope for this top line would be 1/2. And I totally realize this is going to be difficult to write on your graphic organizer, on your Google Doc, and that's okay. We'll represent this in the next slide, so don't stress it too much here. I just want us to see where we're getting all the information. All right, so doing that down on the orange line, the bottom line, I'm going to go find a point. So this time I'm just picking one over here. And again, my goal is to count the slope. And so I'm going to see how I get from that point to the next one, going towards the right here. So I go up one and over two. So that was rise one and run two, which ends up giving me a slope of 1/2. Okay, so the goal was we know that the slopes for parallel lines have to be the same or equal. And now that I see those slopes, I see they are the same. So let's go to our evidence though and go ahead and describe this in our evidence. So for line one, this is the top line, I counted the slope. So it's giving your evidence. I counted the slope as 1/2. So you're saying you counted it, and then what the actual value was 1/2. Actually, I might write that a little differently because it sounds confusing. I counted the slope as rise one, just making it sound a little smarter, and run two. The slope is 1/2. And then I would say a similar thing for line 2. That was the one on the bottom. I counted the slope as rise 1 and run 2. The slope is 1/2. All right, so that gives us our evidence. This is our information, what we're going to base our final response on. So we know that parallel lines need the same slope, and we have counted the slope for each line. So those are kind of our 3 main points. And okay, then we're going to go to our reasoning. So our reasoning requires that we go back to the claim. So the claim was that the lines in the graph are parallel. So the claim that the lines are parallel, notice I kind of shortened it up a little bit, that's okay, is, and here's what I need to say, is it true? Is it false? Is true since the slopes and here's where I'm giving my reasoning. I'm going back to my evidence and talking through that. So actually I might do it in the order that I have my evidence rather than what I was starting to write. Sorry guys. All right, let's do it in the order that I have. Since the slopes of parallel lines, oopsie, I missed lines. Whoops. Since the slopes of parallel lines must be the same or equal, and each line had a slope of 1/2. So I kind of, just to clarify, so the beginning I say that it's true, the claim is true, and then here's that key word, my since, this is my reasoning, since the slopes of parallel lines must be the same. If we go back to our evidence, that was our first bullet point, the slopes must be the same. And then, and here's the remaining evidence, and each line had a slope of 1/2. And that was the second part of my reasoning. Those 2 other bullet points, the 2 other stars, each line had a slope of 1/2. So there you go. There is our CER. And that's going to wrap it up for these notes. See you later.